In this lesson, we're going to be discussing geometric constraints. There are several different types of geometric constraints, each with a specific capability and purpose. The selection you choose depends largely on the design intent. As you create sketches, some constraints are inferred or applied automatically. In most cases, inferred constraints are sufficient for your initial constraints. As you continue to develop the sketch, you may need to add additional constraints to properly stabilize the sketch geometry. Geometric constraints stabilize sketch geometry by placing limits on how the geometry can change when you attempt to drag or dimension it. For example, if a horizontal constraint is applied to a line, then that line is forced to remain horizontal at all times. Let's open up a drawing and do an exercise together. Go to Open, and we're going to open up the drawing Applying Geometric Constraints.ipt. This is a part file with no parts in it, only one sketch. If you double-click on Sketch 1, it'll take us into the editing environment. And what I've done is I've given you a before and after. So I encourage you to go through this with me as I go through them and try to apply the constraints as I do them. In the previous exercises, we may have turned off constraint persistence. Doesn't really matter because we're not going to draw anything, but it's a good idea to go ahead and turn this back on. I encourage new users to leave this on whenever possible. If you want to look at what the constraints are that I've applied, we can either come up and show constraints, or you can go right-click, say Show All Constraints, to see what was already there. The first one we're going to look at is the tangent constraint. It's the circle with a line kind of at an angle. It almost looks like it's tipping its hat to you. We're going to select that constraint, select the circle, and then select the line. Circle, line, or line, circle. Doesn't really matter which order you select them in. And so now I have my tangents on there. By hitting F8 to show all constraints, that is not dynamic. So every time I add a constraint, if I want to see it, I need to hit F8 again. So now we can see that these lines are all tangent to one another and tangent to the circles, and it's one big giant happy family here. You will notice that the lines don't actually reach the circle. Even though they're tangent to the circle, they've stopped short because they weren't fully constrained to start with. Easiest way to fix this is go to the Extend command and extend it out. If you hit F8 again, now you see that it looks like the finished sketch. The next one we're going to talk about is perpendicular. Those of you who are familiar with AutoCAD will be very familiar with the perpendicular constraint tool. It works a lot like OSNAPs. The only difference is it doesn't matter which order you pick the lines in. You notice when I picked the line going up and down and then picked the bottom, it made it perpendicular alright, but it rotated out my first line I chose. If I undo, select it again, and go in the opposite order, select the bottom and then select the left, then it rotates the bottom down. The first line you choose is the line that Inventor is going to move. If they're already pretty much perpendicular, we don't have to worry about it too much. The next constraint is the parallel constraint. Come up here, click on it, select our first line, our second line. Once again, Inventor moves to the second line. So if I like one angle better than the other, I need to make sure that I pick the angle that I want to keep second. Once I've chosen parallel here, for example, doesn't mean I can't move my geometry around. It's going to allow me to maneuver it however I want to finagle it. It's going to let me change the angle. It's just going to lock the two pieces of geometry to each other. Next, we have coincident. It's the two lines coming up here running into each other with a little dot. Click on that. I call this one the point-to-point constraint because it gets very hectic with coincident, collinear, and concentric all on the same line, and coincident and collinear look very similar. So I call the coincident constraint the point-to-point. This is what gives you a closed loop. If you click on one end and then another, it'll bring it up and close it. The AutoCAD users out there that are familiar with polylines, this basically is converting a standard line into a polyline. It keeps it connected at all times. Very, very important for Inventor whenever you're doing features to have closed loops. You don't ever want to leave a corner unclosed. always verify that all the corners are closed. With the coinciding constraint, a couple years ago, Autodesk actually changed the way that it shows it. It used to show us the actual little coinciding icon here every time where there was a joint. The problem is there's two icons because there's two connections there. Both lines are connecting, so then therefore there's two different points. Because of this, your sketch could get very crowded very quickly whenever you're trying to edit your geometric constraints. So instead, Inventor added this little yellow dot that if you hover over and click on, will give you your coinciding constraints. You can still move it around and see it. If I want to delete it, I can click on it and select delete, and it'll go away. It just collapses it down to make it a much more compact and easier to use glyph and not getting in your way all the time. The next one down is concentric. If I click on the concentric command, all I have to do is select on two arcs, or an arc and a circle, or two circles, and it'll automatically bring that circle in. It's not going to adjust the size of the circle, it's just going to lock that circle to the arc. Now, as easy as that is, a quick tip here, if I undo back, and I just grab the center of the circle, and drag it over the center point of the arc until I get the green dot, once I let go, I get the same results. The only difference is when I hit F8, I don't actually have a concentric constraint on it. I have a coincident, because what I did was I locked the center of the circle to the center of the arc. Really and truly, these two commands work the same way on two circles like this. It's 6 of one, half a dozen the other, depending on what you need it to do. This is just a little faster, saves you a step or two. Neither way is right or wrong, it's just an additional option to you when you're designing. The next one down is collinear. It's very similar to parallel, except for parallel, the two lines could be separated. If I were to make these two lines collinear, they would be on top of each other. Collinear is really good for lines that are out away from one another like this. If you want this to be even across the board, it's going to be the legs of something, it's going to be the ends of a sheet of metal or something like that, then you use the collinear. If you want this line and this line to be on the exact same angle, then you'd use parallel. Horizontal. Looks like the little saw blade up here. Pretty straightforward. Does what you ask it to. Click on that line, it makes it horizontal. The trick is, you can use horizontal for more than just lines. If I pick on the center point of this circle to the center point of this circle, now these circles are going to be locked on a horizontal plane, and if I move one, it's automatically going to move the other. I can actually use horizontal on vertical lines as well. Let me show you that. I click on horizontal again, click on the center of this circle, for example, and I come down and find the midpoint of the line by getting the green dot. It will actually lock the circles to the middle of this object. It's very similar to symmetrical without the need for a center line or drawing a construction line and locking it to it. Basically, this saves me that extra step of drawing another line. Vertical looks like the vertical saw blade. Click on that, click on a line. You notice that it changed this line here that was horizontal. There was not a horizontal constraint on this. That's the reason it modified it. It said, hey, you wanted this angle to be the same, so I'm just going to rotate it up to make this line vertical. If this happens to you, don't freak out. Just use the perpendicular, or you can use parallel. We hit escape here. We can bring our shape back down. The additional options with vertical is I can use it on, once again, a horizontal or non-vertical line. I select on the center of this line and the center of the top line. Now as I move my drawing around, this line's always going to be held in the center of this. Doesn't matter what angle it is, because I locked the center of it to the center of the other line. Doesn't matter where this line goes, it'll always be locked there. As my shape changes, it's going to remember that these are vertically aligned. Just another tool to add to your toolbox to be able to work more efficiently in sketching environment. Next we have equal. Say two circles are equal. You can also say two lines are equal. It's a very powerful tool, very simple, not a whole lot of explanation needed. Next, we have the fixed constraint. If you have a very complex shape and you're doing a lot with it, have a lot of constraints in here, a lot of control, but let's say I'm doing something else and I need to dimension to it. If I was to try to dimension to this shape, say to that there, put a dimension on it, it actually moves my geometry up to that secondary shape. Well, what if I'm still working on this, but I need to lock it down for something? If I undo this back, what I can do is select it and hit the little padlock here. Turns it black, tells me that it's fully constrained. Make sure I hit escape after I do it the first time. And it won't let me move it. It's all locked down. Now, this is not a substitute for a fully constrained sketch. Even though technically it would make it fully constrained, you do want to do it as few steps as possible, but not completely lock yourself out like this. It could get very frustrating if you came into a very complex sketch and a part of it was locked and you couldn't figure out what it was to be able to adjust it. I always tell people if they use the fixed constraint, use it sparingly and then turn it off when you're done. Easiest way to turn it off is just select it and hit delete on your keyboard. Ideally, you wouldn't be doing this many points whenever you're doing a locked or fixed constraint. But try not to leave it locked, because it could come back and bite you later on. Next, we have the symmetrical constraint, and this gives us a good example of why we should do a fixed constraint temporarily. The center line of this symmetrical constraint is not locked down to anything. But I know from experience, whenever I start applying the symmetrical constraints, it's going to want to move this line around. So what I'll do is I'll go ahead and add the fixed constraint to the center line. Because it is just construction geometry, I don't really have to worry about dimensioning it or actually knowing where it is, because I'm going to be able to come back and modify it later. I can now activate the symmetrical constraint. Select two lines that I want to be symmetrical to each other, and then select my center line. Once you select the center line originally, you don't have to select it again. Inventor understands that you want to use that same center line. If I was to use a different center line or wanted to use a different center line, I can right click and tell it to restart. But I'm okay using the same center line. And I can come in here and lock this down. I may even need to come in here and do a couple more collinear constraints. And you'll notice once I move one side, it moves the other side. You can do a parallel constraint. Tangent maybe. And now I get a nice clean sketch. If I hit F8, I can see all the constraints that are involved in that. Symmetrical is a very powerful tool. And when we get done with this next constraint, I'm going to have you do a more walkthrough exercise. The last constraint is the G2 constraint. It's very similar to tangent. What it's used for is when you're dealing with splines and you want a very smooth edge. I click on the G2, select my spline, and then I select an arc, and you can see I get a perfectly smooth edge. The best example I've ever heard of this is sitting in your hand right now. If you look down at your mouse, I guarantee you there are lots and lots of angles and curves and grooves, and usually it's a beautiful shape. Even the cheapest $5 Dell mouse is still a beautiful shape if you really think about it. Somebody spent a lot of time making sure that you can't feel where the edge of that mouse is. Even though there's a radius on it, and you know that the top of the mouse is a lot flatter, almost horizontal compared to this edge of the mouse, you can't tell where one plane ends and the other begins, because it has a G2 constraint on it. It's perfectly smooth. And there's actually a mathematical formula that's involved in that, but just kind of a brief overview of the G2. All right, now what I have for you are some hands-on lessons. I'm not going to go through these because I want you to go through and add the horizontal constraint to this line. I want you to add the horizontal constraint to the centers of the circle and the edge of the rectangle. I want you to add the equal constraint. And then I want you to make this symmetrical component here. The finished is on the right, and I'm not going to walk through it like I said because I want you to learn how to do it on your own, and I believe that if you don't fail, then you'll never learn. I believe you have enough skills now to start constraining a sketch on your own. When you're done with this, you can save and close.